Hello my dear students, we will learn today finding the values of trigonometric ratios. Exercise 8a, page 241, MBOSE Maths book, class 10. Question number 1, see, in triangle ABC, right angle at B, if AB equal 5, BC equal 12 and AC equal 13, find all the 6 trigonometric ratios of angle A. So, let us draw the right triangle ABC, right angle at B. So this B is the right angle. We have to show it by symbol. This is by symbol. Angle B is right angle. And now AB is 5. We can write here AB is 5. BC is 12. We can write here, and AC is 13. We have to find all the 6 trigonometric ratios of angle A. So remember the first lecture we explained about the trigonometric ratios, the 6 trigonometric ratios. We have to find those trigonometric ratios with reference to the angle A. So let us write here what are given. Is given AB equal 5. We can write here given. This is solution. AB is equal 5. 5 unit you can say. BC is equal 12 and AC is equal 13. So with reference to angle A, the 6 trigonometric ratios, the first one is sine A. Sine A. We explained with theta, so here direct the angle A. So let's see, from angle A is the unknown angle. From angle A, the opposite side will be perpendicular. So this BC is our perpendicular. We can write here P is equal 12. And from right angle is B. The opposite side AC is our hypotenuse. We can write here AC is equal 13. And the third side remain AB. It is our base. We can write B for base. Base is 5. And now we will find the 6 trigonometric ratios. So think for sine A. First trigonometric ratios is sine A. So with reference to angle A, we can mark here angle A, and this is like our, say, theta. If we want, we can write also the unknown angle. So now sine A, what is the formula? Think the formula, perpendicular by hypotenuse. You can write here perpendicular by hypotenuse. And look here, what is perpendicular in the picture? In the figure, it is BC. We can write here BC, and hypotenuse is AC. And write the value of BC. BC is 12, and write the value of AC, it is 13. So we get sine A equal 12 by 13. The next trigonometric ratio is cos A. Cos A, think the formula, base by hypotenuse. B for base, A is for hypotenuse. So what is base in the figure? AB is the base and hypotenuse is AC. So write the value of AB, it is 5, and AC is 13. And the next is tan A. Tan A formula is perpendicular by base. So what is perpendicular in the figure? It is BC. And what is base in the figure? It is AB. Write the value of BC, it is 12, and value of AB, it is 5. So these are the 3 trigonometric ratios, first 3. And the next 3 ratios, let us will do it here. So opposite or the reciprocal of sine A. Reciprocal of sine A is cosec A. We can write here cosec A. The formula for cosec A, just opposite of sine A. Here is hypotenuse up, perpendicular down. So just make it opposite. AC is up and BC is down, and 13 is up and 12 is down. You can do it just closing your eyes also. And then opposite or reciprocal of cos is sec A. We can do here sec A. Just make it opposite here. Hypotenuse up, base is down, and AC is up. This AC is up, AB is down, is equal, then 13 up and 5 down. And then reciprocal of 10A is cot A. Cot A. So base is up, perpendicular is down, AB is up and BC is down, and these values 5 is up and 12 is down. So these are the 6 values of the trigonometric ratios, 6 trigonometric ratios. So this is our sum, question number 1, and similarly we can do for question number 2. Let us try for question number 2. Question number 2. In triangle ABC, right angle at A. Look here the figure ABC. Right angle is here at A. The name of the angle is changing. Okay, right angle at A, and AB equal 4. AB is 4. We can write here AB is 4. AC is 3. Here is 3, and BC is 5. And now we have to find all the 6 trigonometric ratios of angle B. With reference to angle B, we have to find, we can mark this angle B, and yes, for help we can write here theta also. And now first thing, you have to know the name of the 3 sides correctly. See, from right angle, the opposite side, this BC is the hypotenuse. Now we can write AC is equal 5. And from angle B opposite side, this AC is our perpendicular. We can write here P is equal 3. And the third side AB is our base. So base is our 4. And we can write now, given solution, given AB is 4, AC is 3 and BC is 5. So the first trigonometric ratios, we will find all the 6 trigonometric ratios with reference to the angle B, So this time the name will be sin B, cos B, tan B, etc. So sin B, think the formula. Sin formula is perpendicular by hypotenuse. We can write here perpendicular by hypotenuse. So what is perpendicular in the figure? Look the side, perpendicular is AC. So we write here AC, and hypotenuse is what in the figure? It is BC, and write their values. AC is 3 and BC is 5. So sin B is 3 by 5. And think the next cos B. Cos B is base by hypotenuse. So what is base in the figure? It is AB and hypotenuse is BC. So put the value of AB, it is 4, and BC is what? BC is 5. And then is tan B perpendicular by base. So what is perpendicular? Perpendicular is AC in the figure and base is AB. So write the values of AC. AC is 3 and AB is what? 4. So we get the values of sin B, cos B and tan B. And now we will write the next 3 trigonometric ratios, which are the reciprocal of the sine, cos and tan. So remember, what is the reciprocal of sine B? It is cosec B. Cosec V. So this formula, just make it opposite. The hypotenuse is up and this perpendicular is down, and similarly take this BC up and AC down, and the values also automatic, it will be down 5/3. And then reciprocal of cos B is sec B. Sec B, just make opposite here, hypotenuse by base. So we will have BC by what? AB, and is equal 5/4. And think for tan B, its reciprocal is cot B, and the formula, make it opposite. Base is up and perpendicular is down, so AB by AC is equal 4/3. So these are the values of 6 trigonometric ratios with reference to the angle B. So remember, when we find the value of angle B with reference to angle B, the from angle B opposite side will be perpendicular, and what we said, from right angle always the opposite side is hypotenuse, and the third side will be our base. And while doing this sum, this formula sine, cos and tan, for these three formula you should have ready always for this formula. And I gave that sentence, if you remember, some people have curly brown hair turned perfectly blue. So if you remember that formula, some people have, you see, so sine is equal, people have perpendicular by hypotenuse, and curly brown hair, curly, this C is cos, base by hypotenuse, brown hair, and tan is turn perfectly blue, so turn is tan, perfectly blue is perpendicular by base. So we have got these 6 trigonometric ratios. Next we will do question number 3. So now question number 3, here the value of sin theta is given. Question 3.1, sin theta equal 8/17. Value of one trigonometric ratio is given. We have to find the values of other 5 trigonometric ratios. Before doing this sum, let us know this point. Already you know, in a right triangle by Pythagoras theorem, what we know? Square of hypotenuse is equal to sum of the squares of other two sides. So we write a square is equal perpendicular square plus base square. That means from the right angle we take the opposite side as what? Hypotenuse. So our hypotenuse is AC, and if our angle A is theta, then from theta the opposite side we say perpendicular, and the third side we say what? Base. AB is the base. So we have this formula, a square equal p square plus b square. Then from here see, we can find the value of p square. We can write, suppose b square we take left side, so it will be a square minus b square is equal p square. So we write here p square is equal a square minus b square. And similarly we can find b square. Suppose I take this perpendicular p square left side, it will be a square minus p square is equal b square. So we write it b square is equal a square minus p square. So our main formula is number 1, a square equal perpendicular square plus base square. Then from here see, we can say hypotenuse is equal square root of perpendicular square plus base square. Here is a square equal p square plus b square. So a is equal square root of perpendicular square plus base square. Similarly, when p square equal a square minus b square, we can get p is equal square root of a square minus b square. And also for base b, we can find square root of a square minus b square. So these three formulas we will try to use in this question number 3. So let us see question number 3.1. Sin theta is equal 8 by 17. So this solution, sin theta is equal 8 by 17. Let us write the formula for sin theta. Remember the formula, perpendicular by hypotenuse. We can write it here. So we can say perpendicular is 8 and hypotenuse is 17. So we have to find what? Base. This formula we have to use. Base is equal square root of a square minus b square. So we can write here, therefore b is base. Base is equal square root of a square minus p square, perpendicular square. So is equal, we write here, what is a? It is 17. So 17 square minus perpendicular is 8, it is 8 square. So we continue here. 17 square is 289. Multiply 17 by 17 minus 8 square is 64. So we can continue here. 289 minus 64. This is 225. 225 square root of 225 is 15. So we have now base is 15. The perpendicular is 8 and hypotenuse is 17. When we know all the three sides of the right triangle, we can find all the trigonometric ratios. Now sin theta, one ratio is given, we have to find the other trigonometric ratios. So think for now, then next of sin theta is what? Cos theta. Sin theta already given. So cos theta formula is what? Base by hypotenuse. Have to remember the formula. So what is base here? 15. What is hypotenuse here? 17. And then think for tan theta. Tan theta formula is what? Perpendicular by base. So perpendicular is 8 and base is 15. And then opposite of tan theta, reciprocal of tan theta is what? Cot theta. Cot theta is, here is base and perpendicular is down. So we can write 15 by 8. And now reciprocal of cos theta is, here I write sec theta. Sec theta is equal opposite of this cos. This hypotenuse up, base is down. H by b. So we will get here 17 by 15. And then 3 on 4 we have got. Then reciprocal of sin theta, it is what? Cosec theta. So we can bring that formula from sin theta. This hypotenuse is up and this perpendicular is down. So we can write 17 up and 8 down. So these are the 5 trigonometric ratios, the values we have got 1, 2, 3, 4, 5. So next is question number 2. Sin theta is given root 3 by 2. We have to find the other trigonometric ratios. So let us see. Sin theta is root 3 by 2. We write sin theta equal root 3 by 2. So remember the formula, same as before, perpendicular by hypotenuse. So we can say perpendicular is root 3 and hypotenuse is 2. So what we have to find? Base. We can write base is b. Formula is what? Hypotenuse square minus perpendicular square. So we write this square root. Hypotenuse value is 2. So it is 2 square minus perpendicular value is root 3. It is root 3. Can give whole square. So next is here 2 square is 4. Root 3 square is 3. 4 minus 3 is 1. And square root of 1 is what? 1. And then we can find now all the 5 trigonometric ratios, because we have all the 3 sides. You see, base equal 1, hypotenuse equal 2, and perpendicular equal root 3. So next of sin theta is what? Cos theta. Cos theta. What is the formula? base by hypotenuse. So what is base? It is 1. And what is hypotenuse? It is 2. So cos theta is 1 by 2. Next is tan theta. What is the formula? Perpendicular by base. So write the value of perpendicular. It is root 3. Here is perpendicular, say root 3, and base is what? Base is 1. So we can write root 3 by 1 is equal root 3. And then opposite, this reciprocal of tan theta is cot theta. So cot theta, it is opposite of this formula. Base is up and perpendicular is down. So 1 is up, root 3 is down. So this is our cot theta. And now reciprocal of cos theta, I write it here, sec theta. Sec theta, just this hypotenuse up and base is down. So it will be 2, hypotenuse is 2, 2 by 1. 2 by 1 is only 2. And then we have this sin theta. Then reciprocal of sin theta is what? Cosec theta. Cosec theta, just make this formula. So hypotenuse up and perpendicular down. Hypotenuse by perpendicular, and the value from here 2 up, root 3 down, 2 by root 3. So these are the 5 trigonometric ratios from this sin theta. So these are the answer. Okay, thank you my dear students for today. So we will continue. You keep on practicing. Thank you.